Hello, welcome to Code with Richard, and in this episode, I'm going to solve LeetCode problem number 53, maximum subarray. And the problem is as follows: given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. And the LeetCode website gives a couple examples, one of which is here, and there's also constraints. So one of the constraints is there's always going to be at least one or more number in nums. And so in this particular subarray, you can see if you look at these particular numbers right here, the 4, -1, 2, and 1, you'll see that if this is a subarray that's chosen, this adds up to 6. And so I'll just put this over here. The output is 6. And so one thing to note is we don't necessarily care about identifying which elements in the subarray. All we care about is what is the sum that we get from this subarray. I personally found this particular problem to be a little bit tricky, and it took me a while to come up with a solution that would work. I first started with the brute force solution, which was taking first a subarray size of 1 and looking at all the elements, picking out the max, and then an array size of 2, and basically sliding this window to get every 2 element subarray, and you can do that with 3 elements as well. That would work functionally, but I knew going in it probably wouldn't cut it. There are some hints about getting a big O of n solution to this problem, and actually that's something that I thought about and I discovered. One thing that really helped me was the realization that we only care about the total sum. So in this particular case, there's one thing that I noticed is that because we only care about the sum, if you have 2 positive numbers that are next to each other, you could actually combine this. Like the 2 and the 1, it could just be a 3. And if it was made into a 3, it actually does not affect the final result. So in the first case, we combine those 4 elements, and if we combined, it could look like these elements, these 3 elements. So that's one. That was the first part of the optimization that I thought about, is when you have consecutive negative numbers or consecutive positive numbers, they can just be combined together. And in which case, we can see here that this list of nums is actually reduced. You have a negative number, positive number, negative number, positive number, negative, positive, and so on and so forth. But you can actually do this in big O of n, because we can actually reduce this even further. We can do this in a single pass. And my logic was as follows. Basically, any single element can be the largest element. So as we traverse, we want to keep track of any element that may happen to be the largest element we've seen before. But also, we might be able to combine elements as well. I mean, in this particular case, there's -2. When we see it doesn't really help us much, we don't want to combine this with the 1. So we can just remove that. But the thought was, well, if I have a number here, and let me just change this. Let me say this is 6. If I have 6 and I add it to any array larger than 6, well, my next one's a negative number. So that by itself may not necessarily tell me if I can add it to anything that's beyond it. But I was thinking, oh, what if I add 6, the next negative number, and then the next positive number, or a sequence of positive numbers? Is it beneficial to add 6 and this -3 to whatever is after it? And in this case, it is, because if you add 6 and -3, you get 3. You add that to 4, you get 7. And so you get a net positive benefit by adding these 3 together, because the 6 is greater than this -3. However, if we had something that looked like this, and let's say there's other elements after it, would I want to combine the 2 and the -3 to this 4? And the answer is no, because it would actually give me a value less than 4. And so I had this idea of, let me just call this like a running total. Like, I have a running total. I'm going to be 6 here. I subtract 3, which is okay. But my running total still net positive is 3. But once I hit another positive number, because I have a positive running total, I can add that to whatever I have here. So if I have a running total of 6, -3, and I add that to 4, that basically just means that I've combined these elements together into a subarray. And now I have a new running total. Whereas in this case, the second case where I have 2, -3, my running total is negative. So there isn't a case where I would want to add this to the next element in my array. And so this is kind of like the idea that I'm going by, is like I have this running total of like the previous elements, what the best running total is, and using that, and depending on if the number is positive or negative, will tell me if I want to keep adding to that total or if I just want to start over. And so let's go into the code. I'm going to create a variable called running total, and I'm going to create another one called best sum. And again, what I mentioned earlier is that best sum could in fact be any individual element. If all the positive elements are by themselves and they're surrounded by negative elements, the largest positive number is going to be our best sum. So we do want to check each individual number as we go along. And so we can just start off with a simple and just iterate over this array. So for num in nums. And so the first thing I'm going to check is that check individual numbers. It could be the best. And actually, I'm going to change this to none. I think that being 0 is actually not going to work because all the numbers in the array could be negative, and in which case you want to choose the least negative number. Okay, so if my best sum is none, or my num is greater than my best sum. Basically, best sum is none. The very first element I'm going to pick as my best sum. For subsequent ones, if my current number is greater than the one I've seen so far, then I can say that my best sum equals none. Okay, and then now, so that's basically the checking individual numbers and the first number. And now I want to split my cases if I have positive or negative. So if num is greater than 0, I have positive. And let's go to negative. Okay, so what happens when I see a positive number? We can go back up here. Let's say we're at, let's take these cases and let's make it a little simpler. Say ... I like to show this, say, hey, the first time I'm going through this, 6 is my num, and my running total, I'll just say my total is 0 at this point in time. And I can't do anything with this. All I can do is go to my next iteration. All right. So, well, actually, no, let me take that back. I can do something with this. I see a positive number. I'm going to add that to my total. So I see a positive, add to running total. Okay. It actually is, there's a little bit more subtle to that. There's another case, but we'll get that when we hit this 4 down here. So then in the next iteration, we are running total 6, and we hit a negative number. And in this in this particular case, I want to add this to my running total, But that's if, and only if, my running total is greater than 0. Because if this is a really big negative number, then, like, if this was like, say, 30, for example, then I don't need to add it. My running total I can just say is 0. And I can go to my next iteration. here. Let's put a little caret here. Say I'm on the 4. And so my total at this point in time is 3. And again, I see a positive number, so add to running total. So then on the next iteration, my running total is going to be 7. And so as you can see that if I add up, if I have a subarray that contains these 3 elements plus whatever's after it, my running total is going to be 7. And that's beneficial. We can go down to this particular case right here. This one's a little bit different because my 2 is less than 3, so my total is 0. I see a positive number. I want to add it to my running total. So I'm just going to put, we'll put my little caret here so I know I'm talking about that element. And my total here is 2. And now I'm at -3. But in this particular case, I have a negative number. But I don't want to add it to my total. If I added this to my total, this would mean that I'm considering both of these elements I want to carry over as part of the subarray, but it's not because I know that the subarray, the sum adds up to less than 0. So I'm just going to reset here, which basically means I don't want the 2 and -3. It's not beneficial to include those numbers in the subarray. I'm going to reset. So when I go to the next iteration, let me put the caret here so we see we're at 4. I'm going to start off, my total is going to be at 0 because I reset it from before. So there's some logic here that helps us determine what we want to do with the running total. So let's go back down here. So we have a positive number. And basically, it depends on what our running total is. If we have a high running total, we'll just add it, because that means that we're going to include this number with all the previous numbers. So if my running total is greater than 0, let's just add this number here to my num. But if my running total is less than 0, that means that in this particular case, my running total is less than 0. So actually, I'm not going to reset it at this point in time. My running total is -1. My running total is -1. Here's actually where I'm going to reset it, because I'm going to set my running total equal to my current element. So go here, and we'll just say my running total will equal my num right here. Okay. Likewise, if I have a negative number, I'm just going to add this to. I'm just going to add whatever number I have, and if it goes really, really negative, that's okay, because once we get our next positive number, if we happen to have a net positive, then we can add it. If not, we'll just reset. And now I've updated my running total. And my running total may be best. So I'm going to say maybe update best sum. Okay, so if my running total is greater than my best sum, and I'm going to say my running total is greater than 0. So my best sum is equal to my running total. And then we'll just return best sum at the end. Now let's go up here to make sure that my indentation is okay. Okay, so I have this code. Let me go over. I have some tests right here, and so this is the example that they showed. I have some other examples also with my input with 2 negatives and also with 0. So we'll go to my test, and we'll see my test run. And so I'm confident at this point in time that this solution is pretty good. So yeah, this is my solution to this LeetCode problem, maximum subarray. If you have any questions, please leave them in the comments. If not, I hope you enjoyed yourself and hope to see you next time. Thanks.